That's an yield loss.
Yes.
Okay. So now let's come to decoder design. Now it might appear to be simple. Oh, you just need to make a 9 to 512 output decoder. But it is not as simple actually. How you design a row decoder, how you design the decoding circuits has a very strong impact on how the memory is organized. So for example, it would define how the words are scrambled inside the memory. So what is scrambling? Did we discuss that already?
Sir, bit interleaving if I'm not.
Huh?
Bit interleaving.
Yeah, bit interleaving. So that is one aspect of it. Let us say there is this memory. I could start to write word 0 here, or I could write to start word 0 from here. Is it right? I could have row 0 selecting the topmost row, or it could be selecting the bottommost row. That is a choice as a designer I have, na?
Yes, sir.
Or I could actually write row 0 somewhere here and then go this way and then go that way. I can do whatever I wish to do as a designer. Are you able to see this?
Yes, sir.
So this is what we call as scrambling. Memory bit scrambling, where are different words and bits corresponding to different addresses. So when a particular address is asked for, which row gets selected? Does this row get selected, or this row get selected, or which column gets selected, this one or this one? Why do you think this information is important?
Sir, for correct read and write operation. I mean,
जो भी आपने एड्रेस दिया वही हर बार सिलेक्ट होगा, तो करेक्ट रीड राइट तो हो ही जाएगा. ये थोड़ा ना होगा एक साइकिल में एक एड्रेस गया, दूसरी एक रो सिलेक्ट हुई, दूसरी साइकिल में सेम एड्रेस पे दूसरी रो सिलेक्ट हो गई. दैट लॉजिक यू कैन नॉट चेंज. इट इज हार्ड कोडेड. यू हैव NAND gates, you have everything hard coded inside your memory. So why is this information important?
Sir, apparently it seems कि अगर हम हमारा शायद से जो हमारा IO सर्किटरी है मक्स है उसका डिजाइन में शायद से चेंजेस आ जाएंगे मे बी.
वो तो मैंने चेंज करके इसको कर दिया चेंज. दैट इज फाइन. But why is it important? Why do, as a designer, you need to know it? Why would a SOC designer also need to know it, if at all?
sir, for testing to see if it's working fine or not. I mean,
So testing mein to you can simply read and write into one location and see if it was what you had written is what you read. That is good enough.
sir, when we select, sir, a doubt, sir, over here. So when we select, how do we see if one particular memory cell is being selected or not with the help of I'm like this select lines only, right? I'm like I'm sorry, the row selector, right? Row selector and the column selector, right? So अगर वो ठीक तरह से काम कर रहा है कि नहीं वो check करने के लिए I was saying that actually I'm like it's
So look
needed.
at it like this. I said that this should be row 0. I said that. Okay. However, I ended up designing this to be row 0. Will it change for the user anything? No. User sent an address for row 0. In one case, this row would have been written into and read, or in another case, this row would have been written into and read. Whatever I wrote, that is what I am reading. For the user, it is not changing anything. How will the user make out whether the bottommost row has been selected or the topmost row has been selected? Can the user make out?
No, sir. I was speaking from the designer perspective actually. So designer
Even as a designer, you put something on silicon, you wrote and you read. Can you make out where the row was?
No.
So for all practical purposes, do you need to know the scrambling? And the practical purposes that you are telling about, do you need to know that scrambling?
No need, sir, actually.
But then I'm still talking about scrambling, and I'm saying that this is important to understand. Why?
So maybe when we program or defining memory map for peripherals or an SOC, we need this information to optimize the top system level program. Maybe.
Okay. Other ideas?
Sir, maybe if this memory mapping is present with us, then we can choose the rows where the data has to be written apart, which are frequently used, so that the crosstalk can reduce something of this kind.
Yeah. So thank you, Ranjit. Let me say that I was I read the entire memory and two particular addresses failed. Now, if I do not know the scrambling, I would not know that these two addresses that are failing are actually right next to each other. Those rows are placed right next to each other, and they are failing because there was crosstalk between them. So I need the scrambling information to debug. That is one aspect. Then some of you also mentioned, if I know the scrambling information, I can somehow design better, in the sense that I can say that there is this my entire memory there, okay, and that memory is split into, let us say, banks. So I would say that I would want to distribute my reads across banks so that none of the banks is overly stressed. So I would deter and I would write my data into different banks, even though they are consecutive data. So this is word 0 in one bank, word 1 in the other, word 2 in third, and word 4 in the topmost bank, or word 3 in the topmost bank. So I know that, okay, I may write consecutive words, but in the memory, let them be spread far apart. Why? Simply because when I will read them again, I will be reading them one after the other. Then let me not stress any one bank too much. None of the banks should be stressed too much. I need 4 consecutive words, so I will actually access all the 4 banks, and it should be fine. I would not degrade any bank. I would not cause aging, too much aging on any bank. I would not cause too much stress on any bank. So I'm not saying you should do this. What I'm saying is, if you know the scrambling, you can start to think on these lines.
सर
Yes.
सर स्क्रैम्बलिंग से आप यही बोल रहे हैं कि अगर मैं कन्वेंशनल डिजाइन देखूं तो मैं वर्ड 1 वर्ड 2 वर्ड 3 वर्ड 4 एक सॉर्ट ऑफ एक लॉजिकल कंसेक्यूटिव ऑर्डर में कर रहा हूं, बट उसकी ना करे हुए मैं कहीं भी वर्ड 1 वर्ड 0 कहीं भी प्लेस कर सकता हूं, मतलब अलोंग द रो, ऐसा नहीं कि वो कंसेक्यूटिव होना चाहिए. इसको मैं स्क्रैम्बलिंग बोल रहा हूं, राइट सर?
Yeah, let us simply say, abhi, if I want to say word 0, word 1, word 2, word 3 right next to each other in a given row, which address bits will you send to the column mux? Which address bits will you send to the column mux for decoding this? Zero, 1, 2, 3. I want to
सर जो
decode
LSB, सर LSB शायद से
LSBs, address 0 and address 1. Now let me say that instead of word, so this is word 0, this is word 16, this is word 32, this is word 48. Okay, now which bits am I sending here?
सर यहाँ पे आप LSB सेंड करोगे, मतलब कॉलम में MSB जाएगा.
MSB जाएगा,
तो यहाँ पे LSB जाएगा, यहाँ पे LSB.
LSB रहेगा, A0 and A1.
नो सर MSB रहेगा.
MSB रहेगा. What is the
नहीं सर,
MSB?
सर to select this row we need to
Row
select
की बात नहीं कर रहा. I'm asking what happens in the column mux. Which
Sir,
what addresses should go to the column mux?
Sir
sir
MSB.
MSB sir.
MSB. Why do you say MSB? My MSB would be related to my, like, I have a 1K word instance. So I have 10 address bits. MSB डालूंगा तो how will I select amongst these?
सर मेरे वर्ड 0 वर्ड 16 ये एक रो में है और मैं इस रो में जब सिलेक्ट करूंगा तो मेरे साथ सारे सिलेक्ट होने चाहिए, राइट? मतलब वर्ड 0 वर्ड 16 वर्ड 30 वर्ड 48 ऐसा चाहता हूँ सर मैं कॉन्फ़िगरेशन।
वर्ड लाइन तो सबको एक साथ ही सिलेक्ट करेगी ना राघव?
यस सर।
I want
Okay.
to choose one of these words now. What should go into this multiplexer? Which address bit is changing in between them, amongst them? Is anything changing amongst the bottom 4?
No, sir.
Where is the change happening?
Sir, in between.
Six,
So this is 16. So this was initial was 0. है ना? This is 16. This is 32. This is 48. Are you able to see this? So which bits would go there?
Sir,
MSB,
we
sir.
can use MSB.
Talk to
I
MSB.
missed.
Again, this was a 10-bit address.
Oh yeah.
Can you use MSB?
No, no sir.
No, sir.
So what bits are we talking about?
So,
Intermediate sir. I mean,
Sir,
5 and
6 and
6.
6 bits from
A5
there.
and A4.
okay.
So which bits you send to the column multiplexer will decide which words sit next to each other in a row. Do you see this?
So but why will I want to do that? Making so complex it. I mean, I can go
What is
with word
complex in
1.
this? What is complex in this?
So I mean, my question is, ki why would I prefer this over say word 0,
I'm
word
not
1, word
saying
2?
why would I prefer this. I'm saying
Okay.
how you manage the address bus can impact memory scrambling. That how you manage the address
So like,
decoding would impact memory scrambling. Are you able to see this?
okay. So sir, how I'm placing the different words in the array, that is kind of the scrambling, and that will be impacted by how I choose to, which bits I choose to select in the row and the column side.
So the same memory, Raghav, in the same memory, if I just change which pins come to the column marks decoder, the words in that the memory scrambling would change. Nothing else has changed, just which inputs I am connecting to the address decoder on the column side, that will change the memory. Are you able to see this?
Yes, sir, the memory organization will change depending on which bits I'm sending.
Sir, this example seems to be too suitable, sir. So if we take word number 47 over there, then it will be different, right?
Word number 47 is in some other place, yes. It is in some
Okay,
other
so
row.
scrambling, I'm like we do the scrambling based on this two select lines. I mean, we first maintain any two select lines constant and we'll vary those conditions of 4. And according to that, we make scrambling. Is that what you meant? Or I mean,
What I mean is how you connect your address bus to different parts of your circuit will change the memory scrambling entirely.
हाँ sir, वो ठीक है.
That's it.
Oh.
Now, depending on what your purpose is, what your processor needs, what your system needs, you can use your address bus appropriately.
सर इसमें बैंक कहाँ पे था फिर? बैंक क्या चीज थी सर?
मैंने बैंक की बात नहीं करी अभी, मैं तो खाली अभी एक रो के अंदर आपको दिखा रहा हूँ, बिकॉज रो वाली चीज आपको ऑलरेडी क्लियर थी, है ना? रो थिंग वाज ऑलरेडी क्लियर टू यू, सो आई एम जस्ट इलैबोरेटिंग ऑन इट. नाउ लेट्स कम टू बैंक. बैंक वाला मैंने शुरू करी थी बात. या प्लीज. यस.
So sir, ये जो memory scrambling कर रहे हैं, this will be done based upon the my processor needs. What exactly?
You can,
Okay.
or
Okay.
you may not. That's okay.
Okay.
If you want to optimize something, if you are a memory, if you have done this course to now, tomorrow when you go to wherever you go to, as an architect, you know, okay, this is possible and that is not possible. Someone who has not done a memory design course would not be able to handle it like this. Are you able to see this? Now let us say these are my banks. Suppose I want to put word 0 here, word 1 here, word 2 here, word 3 here. Which address bits do I need to use for bank selection?
A0, A1, sir.
A0, A1. Huh? Now, if I say that, okay, it's word 0, word 16, word 32, word 48. Now, which addresses?
A5, A4.
A5, A4. So, again, which address bits you use for bank selection will again define how your words are distributed inside the memory. Huh? Are you able to see this?
सर बट ये बैंक चीज है क्या सर? I mean,
Bank is you've okay. Bank means, let us say you've put extra IOs somewhere. This is hierarchical bitline architecture. We'll come to that a little later, but okay, chalo, let me take it now because it is a part of address decoding only. So let us say I had a memory which had this bigger bitline, this longer bitline, due to which its speed was 2 nanoseconds. Okay? I want to operate at 1 nanosecond. So what I do is I say, oh, this bitline capacitance is huge. Let me separate or split these bitlines into smaller bitlines. Each of these smaller bitlines will be associated with a sense amplifier. And there will be a global line through which I will be able to give an output. What happens? Now, because the bitline capacitance that every bit cell sees is smaller, this access time would come down to 1 nanoseconds. Because you have reduced the overall capacitance. So this is called hierarchical bitline.
Sir, is this same as the page that we discussed yesterday?
Yeah, that is another way of saying that, okay, अभी मैंने आपको vertically place करके दिखा दिया. There could be multiple such arrays which I could place next to each other. And again, one of the address bits would select one of the pages. One of the address bits would select one of the banks. Is this okay?
Sir, I mean, a general question, sir. So, ये scramble जब हम लोग कर रहे हैं ना सर इसमें, so previously during bit interleaving you explained that okay wiring का issue है, so we have scrambled that. इसमें issue क्या हो रहा है कि हम लोग scramble कर रहे हैं at the first place? हाँ, that was my question, sir. What's the issue that we are scrambling actually? I mean, why do we want to?
Suppose you were not using mux. Let us say you were not using mux. 1K words, 8 bits. What would be the aspect ratio of your memory? Why did we talk about scrambling in the first place? Do you remember?
Yes, sir. I mean, different positioning different होगा इसीलिए we were seeing scrambling. But okay, before that, why do we want to actually scramble that? So okay, एक चीज था जो bit interleaving था वो समझ में आ गया. But okay, ये जो भी है word
Scrambling का
0.
मतलब क्या है? Scrambling का मतलब है how are the words placed? That's it. You have to place the word somewhere. Na? If you do not want to give any scrambling information, you have to place them linearly. The moment you say, I will fold the memory and use mux, you need to tell where is which word. Are you able to see this?
Yes, sir.
As soon as you start to use mux, you have to tell na where is which word, which row, which column.
Yes.
That's it. That is what we are calling about. That is where the scrambling thing comes into picture in the first place. Now, you not only use mux, you also use hierarchical bitline. So now you need to know which bank is which word. It is not simple. So as you add more complexity to the array, for whatever reasons, you need to tell the user where is what. Because depending on where what is, let us say a set of 20 words are failing, 24 words are failing. They are not consecutive words. Unless you know the scrambling, you will not be able to make out that, oh, this particular sense amplifier is actually what is failing. You will say, oh, 24 random failures are happening. I do not know why. But as soon as you know the scrambling, you will realize, oh, they're all linked to one same sense amplifier. So it is not that the bit cells are failing, it is that the sense amplifier is failing.
Yes, sir. Yeah.
Are you able to see this?
Mm.
That is why as a designer, you should know how the words are distributed so that if there is any failure, you can quickly tell, oh, this is the common circuit. Oh, that is the common circuit. Okay?
सर इस केस में जो हमारा बैंक है, इस केस में जो पूरा कॉलम है, कॉलम को हम मल्टीपल एक शेड बिटलाइन की बजाय हम एक मल्टीपल बिटलाइंस को हमने तोड़ दिया, मतलब
Yeah.
different parts.
This is called hierarchical bit line.
Okay. And
We
sir,
made the
each
bit line capacitance smaller.
Okay. So sir, like each basically kind of bank will correspond to a certain set of bits of a certain set of words basically.
Yeah.
एक बैंक में कुछ words आएंगे और उनकी कुछ bits होंगी.
Yeah. Okay. So,
So
I would say, think about these questions. What if LSBs are used for page selection? How would the scrambling change? What if MSBs are used for page selection? How would the scrambling change? Similarly, we just did that. अभी हमने अभी यही कर लिया. I would say just stay with this thought and do more of this before the next class. A little bit of it before the next class. Okay. Then we will look into address decoding in much more detail in the next class.
सर एक डाउट था इसी में बैंक वाले में. सर फॉर एग्जांपल जो मेरा एक सॉर्ट ऑफ सेट ऑफ बिटलाइन होगा उसमें हमारे कॉलम्स होंगे. मान लीजिए 5 कॉलम्स, सॉरी 5 रोज हमारी एक बिटलाइन कवर कर रही है, तो उसकी कुछ बिट्स होंगी. फॉर एग्जांपल बिट 0 है हमारी, तो अगर मान लीजिए मेरा वो बिट्स फेल कर रही हैं, मान लीजिए वो वर्ड 1 वर्ड जो हमने करा था वर्ड 0 वर्ड 16 48 32, वो हमारी एक की लाइक कॉलम में उनकी बिट 0 थी, ऐसी आ रही थी. तो अगर मान लीजिए इन चारों की अगर बिट 0 मतलब फेल हो रही है या फिर इनकी वर्ड में रीड कर रहा हूँ तो इनकी बिट 0 फेल हो रही हैं, तो फिर मुझे ये अगर मुझे क्या कहते हैं बैंक पर इंफॉर्मेशन पता होगी तो मैं ये वहाँ पे लोकेट कर पाऊंगा कि वहाँ पे सेंस एम्पलीफायर खराब था, ना कि उन 4 वर्ड्स की बिट्स खराब थी. ये बोलना
Exactly.
चाह रहे सर आप.
Yes.
ओके.
You will be able to localize faults and errors very quickly.
ओके.
Okay. Chaliye. Good guys. Thank you. All the best. And